Hello, everybody, and welcome to Discussions in Orbit, REXUS BEXUS Edition, our new series of live interviews organized by Team DROPSTAR. If you're familiar with DROPSTAR, you know that our team participates in the REXUS BEXUS Programme, a German-Swedish student program where teams from all over Europe are selected to design, build, and execute an experiment in one of the two available platforms, BEXUS, which is a stratospheric balloon, or REXUS, which is a single-stage rocket. In Discussions in Orbit, REXUS BEXUS Edition, we interview fellow REXUS BEXUS teams in order for them to introduce their experiments to the public and share their experience in the program. So today's team is GAMEon.
Team GAMEon is building on the results of their predecessors, Team GAME, a previous REXUS team that proved that a glider being dropped from a sounding rocket can transition into stable flight. GAMEon wants to take a step further by introducing an independent platform for atmospheric measurements. During the flight of the REXUS rocket, the new improved glider will collect data both about its peripheral and flight, as well as atmospheric data, for example, temperature or air pressure. The flight data will be used for improvements and control later on, while the atmospheric data will be available for other researchers. So let's now meet the team behind the experiment. GAMEon, please introduce yourselves to the public.
Hi guys, my name is Timon. I'm the project leader and team manager of Team GAMEon.
Hi, I'm Jonas. I'm the project leader of the electronics team, and I'm also responsible for the hardware and sensor and navigation stuff of the experiment.
And I am Felix, head of the mechanics sub-team, responsible for mechanical design, manufacturing, and keeping an eye on the other mechanical engineers.
Great, so welcome to Discussions in Orbit. And I think, as always, we should start the interview by you introducing your experiment to the public. Can you describe us the concept of GAMEon?
Yes, so we started our experiment with the heritage from the game experiment. So game tried to show that micro collider platform is able to fly self-stable and collect data. We are flying and send this to a ground station. And we used this concept and built a bigger experiment based on that. So we're using more sensors, and the main difference from game is that we have a rudder on the glider, so we are able to steer the glider and fly to a target coordinate. So this is like the main part of the experiment. The glider will be ejected from the rocket and then fly to a target coordinate. And while flying, it will collect data like air pressure and the concentration of methane and CO2, and things like that. And we are also building our own communication ground station. So the glider will communicate with our own ground station, and the ground station will also able to communicate with the glider. So we can tell the glider like fly in that direction or fly in that direction or restart or things like that.
Yes, because one of the big design flaws in the experiment of our predecessors was that the glider was never found after it launched and landed. So we want to make it self-navigating and retrievable. And because of the goal of it being retrievable, we built like a whole communications software department for that.
Sounds like you've got quite a complicated experiment. I mean, you gotta make a bunch of measurements and you also gotta locate it afterwards. So we would expect that you might have quite a big team with multiple disciples within it. Can you describe your team and how it's organized?
Yes, we are 16 members in total, but the number of the team is fluctuating at the moment because as maybe some other teams have already experienced with the extension of the REXUS program, we might save some personal trouble with students being gone or something like that. But overall, we started with 16 members in two teams. We have a mechanical and an electrical department. The mechanical department took care of the design of the glider, of the hull, and the stability. And the electrical department took care of the electronics inside the glider, the navigation and the communication with the glider during the experiment.
Great.
Yeah, yes, maybe to add on that with this. So we're students from multiple departments like electrical engineering, precision engineering, material engineering, and business engineering as well.
There is quite a lot of variety. And what I want to ask you is that you told us that the team is fluctuating, and we also know that your experiment is a build-up of a game, the previous REXUS team. So what, let's start by telling us what are you currently working on improving the experiment?
Maybe you can start with the improvements on electrical.
Okay, so I think at the end the experiment is very different from game. So the mechanical design is much more complex. I think Felix will talk about this later, and the electronic design too. So game was able to use the communication system of Kiruna. So they have like these big antennas there, and they were able to track the glider when flying. But in our case, we are not able to do this because they don't have so many people in Kiruna, or to say it clearer, the Muraba from DLR don't got enough people to operate these big antennas. So we are designing our own communication system, and we're also using another frequency. So game use 2.4 gigahertz, and we are using 886 megahertz. And so the communication system is totally different, and the electronics is a bit more complex. So we have more sensors than game, and we have also the servo engine, which is controlling the rudder of the glider. And at the moment, I'm working on the communication system with some other people. So we are designing our own antennas on the glider and on our ground station. So we are designing a patch antenna. So we're just using like this copper sheets, and at the end we got such antennas. So we have a metal backplate and then the antenna on front of it. And we will have 4 of these antennas on our ground station. So we will use this to communicate with the glider and also to track the glider. So, and the reason we have 4 antennas, we can track which antenna has the most gain and not gain, the highest power at the moment. And so we can track the glider. In addition, we also know the characteristics of the antenna. So we get, in combination with other subsystems, precise location. Yeah, that's what I'm working on at the moment.
Yeah, it looks like you've got quite a lot in common with game, but also expanded heavily on it, improving quite a bit. And I'm thinking that, well, the way I'm imagining it, in the selection workshop, you must have been nervous about differentiating enough from game so as to be selected to actually conduct the experiment. Could you describe to us your selection workshop experience, and if you were nervous or how you prepared?
Well, at this time we have 2 great professors who are big background support for questions, and I remember well that, of course, we had this insecurity if our experiment has enough differences to game, but one professor, he told us that it actually might be a good thing, because in aerospace, heritage is seen as something good, because you can say, well, it at least it worked somehow, and now we're going to improve it. And Jonas was on telephone a lot with Simon Morn from DLR Psalm to ensure that we are going in the right way. Nevertheless, we were really anxious about the workshop. I think for me it was the most stressed out I have ever been for any presentation, because
Wow.
it wasn't just like when I'm giving a presentation for my own good, well, it's fine. I'm telling something. I don't have a problem with this. But I had in my mind, well, we are now 4 people presenting, and this decides over the next, what we thought then 18 months or so, for 15 other people, if we are chosen or not. But yeah, so we practiced a lot, which changed for the later reviews.
Yeah, maybe to add on that, yeah, as Felix said, like the later reviews got really more chill as the time went on. Like there's a saying in Germany, like it translates into they all just cook with water as well. But when we started, like we were really, really anxious, and like I sweated through 2 t-shirts during selection workshop. I remember because like okay, we're speaking with guys with aerospace engineering backgrounds, like such a high standards, and yeah, we're very nervous. But yeah, it went good, didn't it?
Yeah, clearly.
Yeah. And I would like to comment on what you said. Even though the selection workshop and the preparation of the proposal is a team effort, the presenters, I think they feel it in their guts. They're kind of heavy duty that they have. It's
It is because
it is, yes.
you don't get to tell everybody to present, right? You have to choose some people,
Yeah.
and those people have to carry. Like they have to keep breathing.
Yeah.
I mean, it's a universal phenomenon, right? We also had very anxious members. I mean, we were all anxious, but we had some members that nearly fainted.
Yeah.
So yeah, it's reasonable to say the least.
Yeah, but we have to say that it was a very interesting and exciting workshop to take part in, because like a new campaign is coming, and I think that we shouldn't scare the new teams away. It's very fun, and I actually learned a lot of things from the presentations that the REXUS BEXUS team prepared for the selection workshop. I don't know your take on that, GAMEon. Would you like to comment on that?
Well, to maybe expand on one of the stuff you said,
Yes.
I'm actually not sure if the selection workshop usually takes place in person.
Yes.
Okay, so like so for our experiment cycle, we didn't only have like the extension, we also had like the selection workshop being taken online because of Corona. So we had because of COVID, so we had very different experience than maybe some other experiment teams in the past, or maybe the experiment teams will join now. But because with the selection workshop being online, it might have saved us from a bit of trouble, but also added a bit of like nervosity on the other side.
It made timing easier because, of course, you can really prepare your text and kind of read it, and therefore we were really like spot on within 10 seconds
Yes.
on the set time. But yes, I do think so. If I remember right, they gave some presentations on how to approach next in your project. I think, yeah, we learned something right on, and some other things we realized later that we could have learned them right on, and that we should have followed these hints about our experiment organization.
And they also had some technical presentations. So, for example, about GNSS. This was also very interesting for me. So I heard the first time that the power of GPS or GNSS sender is about, I think, minus 130 dBm, which is like nothing. So it was also really interesting. And sorry, to comment on my teammates. So I also think it was quite good that we had our selection workshop online, because we are very anxious and it was easier for us. But as we had the CDR in person, this was so nice. So it was the first time we met all the people in person. We could talk to them. So I think this was a thing which not happened in our selection workshop. So we had these presentations, but they don't talk to each other because you're just online and you don't met people really good in such situations.
Yes, CDR was a very, very pleasant experience.
It was.
I would like to take us back to the experiment for a while. I want you to present to us the timeline of your experiment. So the rocket is launched and GAMEon has to be executed. What is happening on the flight?
We have to think about that. Yes, the rocket will start and it will eject the glider. I can't tell you the seconds, but I think it's not.
After the nose cone extraction.
Yeah. So after nose cone ejection, it's quite logical, but I don't know if it's 90 seconds or something. Nevertheless, so we got ejected, and then at first the glider will fall because there is no atmosphere, and he will be not able to glide.
Actually, this is the really funny part about our experiment, because we have, of course, the launch, the motor burn off, nose cone ejection, then GAMEon will be ejected, and it will be ejected at a height of 80 kilometers, but for the first 40 kilometers we expect it to just fall down until the air is dense enough. So basically we take half the distance for nothing.
I mean,
Because-
basically during re-entry, right?
Don't present it like that. Let's say it more nicely.
Yeah, it's maybe not the best not the best way to present it, but it's really funny, because in the end, rocket for us, it's just a vehicle to bring it up to height. But the interesting height for us is from maybe 30 kilometers and below, because this is where you can actually measure something, where you have air, and the time before we will just watch it fall.
Yeah, so it's not 100% true. So we are able to measure something before, but the time is very short, and some sizes are not measurable without atmosphere. But we'll, for example, are able to measure the temperature and something else. And yeah, after we got in this dense atmosphere, the glider will go into a self-stable flight, and it will start to fly in one direction. And when he flies stable enough, the navigation will turn on. And there are like two cases. The first case is that we have GPS, but we are like not able to count on GPS, because you are not able to use GPS above, I think, 40 kilometers. So it's only for military use above this height. So we have two navigation systems. We have a navigation system with our antennas and photodiodes, which are detecting the direction of the sun relative to the glider, or in another way, so the direction of the glider relative to the sun. Yes, with these two navigation systems, we will be able to find out in which direction our target coordinate is, and then the glider will start to fly to this target coordinate and will collect data while it.
So in summary, it's ejection of the glider, 5 minutes just more or less free fall. Then it will be quite interesting to watch on the ground station if it really enters the stable flight. And then we should have about 90 to 120 minutes of stable controlled flight, and then land. We hope that we maybe can land on the balloon launch pad. Of course, the ideal image in my head is that one of our teammates will just catch the glider from the air.
Oh,
Really
that,
cinematic.
that would be iconic. We need cameras for that.
We need cameras. I'm worried about safety now. Will they allow you to try to land on the field itself?
Not sure. We don't know.
Yeah.
So we are still discussing with the people from Kiruna. But we will land somewhere around the building where we are placed in. So the balloon starting field will be good, but
Yeah,
we'll see.
it's because it's just a big a big flat surface. So we hope that they will be okay with it.
Yeah,
Maybe
and it's not and it's not that heavy, so it's only about 130 gram,
yeah.
something like that.
Yeah, can still hurt quite a bit if it's up to a bit of speed, I guess. But yeah. But maybe to add on to this, maybe from the POV of the rocket timeline, the only real timeline we have is the ejection for a glider at the apogee and after the nose cone ejection. That's the only time we are doing something inside the rocket. And after that, the only thing, or the only timeline we have is the one of our glider outside of the rocket.
Which is nice for us. I don't know if for you guys the interference with other experiments is a big issue. For us, it just isn't, because we will be ejected before the others really turn on, I think, and then, well, we're gone.
Well, I think it's very interesting because in our rocket, if I remember correctly, we have all the experiments that are going to be ejected. So I think it's Boomerang, GAMEon, and the NoseCon trace is going to be ejected as well, right? If I remember correctly. And I think it's in our rocket.
Yeah,
And-
nothing wants to stay in. They just
Yeah,
yeet
and
in
we
your
are
direction.
the only experiment remaining on the rocket actually, so
See ya, guys.
we don't have interference issues.
That's why nobody's consuming power and we get
Is
all
your
of it.
experiment
I mean,
Good for you, I guess.
yeah, it is good for us. We get more power, and yes, it's a bit lighter on the return. Just a quick question: did you guys consider BEXUS, since you don't really care about anything above 30K? I think BEXUS goes to like 25, right? 20 to 25.
Yeah, so we think about BEXUS, but you're not allowed to deploy anything from the BEXUS balloon. So,
Oh,
Yeah.
but
That's
it's good. So we are able to fly with the rocket.
that's actually one of the key takeaways from our experiments, because like we want to build this self-sufficient environmental measuring platform, but in reality it's way more achievable on a balloon than on a rocket. But in this experiment, the only way to deploy this glider was with the rocket, so that's why we choose it.
Okay.
maybe in the end, we will find out that this height range between 30 and 80 kilometers is much more interesting than anyone thought, because of our measurement results.
perhaps,
Let's
perhaps.
see.
I mean, re-entry can be a big challenge to reach stable flight, right?
And
Yeah.
I will have to ask because one of your goals is that you want to build a new platform for atmospheric measurements, as we said in the introduction of your experiment as well. If not, if everything goes well, the concept is proved once again after game now for the atmospheric measurements with GAMEon. How are you going to transition your experiment into something more commercial? Will you always need the rocket? Can it be ejected from planes? Will you still need balloons?
So a more realistic use of the glider will be so these atmospheric measurement institutes are starting like 1, 2, or 3 balloons a day. And normally they have electronics which is on the balloon, and then they fly to a specific height, and then it's gone. So then the electronic is somewhere in the woods, somewhere else. So they are not take the electronics back. So it's a thing of pollution and also a thing of money, because they cost like 100, 200, 300 euro. And this would be a thing for us to do with the glider. So you can use our electronics and our glider, put it on a balloon, do some measurements, and then fly back, and also do measurements while flying. So it's a new.
Yeah, so in the early stages of our experiment, I talked on the phone to a guy from a meteorological institute, asking if, in his opinion, this is any interesting for weather measurements. And he said for exactly this reason, it would be, for him personally, it would be quite interesting to have a glider like this, but built for a normal weather balloon that could be reused.
So in an ideal scenario, we would have like multiple gliders, or like a fleet of gliders being ejected from like a balloon or a plane in different heights or over a different time. So we can have, because we want to make the glider navigatable, we can control the time of descent. And so we have multiple measurements over a bigger area, over a longer time than a normal weather balloon. But that's an ideal scenario we're talking about here.
Also, you could create an epic James Bond style chase scene in the air. Maybe also with boomerang and trace.
I think all of the concepts stated are very interesting. We shall be watching GAMEon for the future.
Definitely. A lot of challenges ahead,
Yeah.
but also a lot of challengers and barriers crossed. So could you describe to us a few of the largest difficulties that you had to overcome up until now?
Well, for our mechanical side, it was that we thought maybe we could just improve it from Game, because Game had basically a flat sheet of foam material for their glider, and we wanted to give it an airfoil so that it can fly a little bit better. With the electronics getting more and more complex and needing a bigger battery, this external design gained a lot of importance to just be able to fly in any way. And we learned that building a glider, which is that small to fit into the REXUS rocket, and then carry this much electronic, it's really difficult to achieve a stable flight. We really underestimated this before. But yeah, now finally we achieved this one.
Just a quick follow-up on that. You have tested your flight? Like, have you dropped your glider from like a high place, or have you launched it in a small altitude and actually tested on that, or is it all just analysis?
No, we relied a lot on testing because actually we don't have an aerospace engineering program or something at our university. We have some dudes that like to fly RC planes in their free time. That's our experience with flight, actually. And so we strap the glider either to a drone or to just a bigger RC plane, go out on the field and eject it from a height of about 100 meters and let it fall off and see how it flies. Yes.
Maybe to add on that, like, we are a very hands-on team. Like our motto from the beginning was test first, verify second. Like we went through, I sent you some of the photos. Like we went through a whole list of design iterations for the glider. Started with a hollow body design, and then went further into our research phase for the prototype. And the glider at the start looks very different from the glider we are working on now. So we did a lot of tests, a lot of test flights, and here we are now.
That's a very
Maybe
nice
this
way. Oh, please
decision will not.
resume. Sorry, I interrupted you. I did not get what you said.
Yeah, just of course, this approach also did cost us a lot of time, but also it was fun.
Of course, of course, it's fun, and I was gonna say that it's a very nice way to go about things. When you're hands-on, it's my personal opinion that you learn a lot more than when you just design.
Says the person that spent months on analysis and designing.
I mean, we had the budget to build it once,
Yeah.
so
True.
if it has to work on the first try, it's kind of different. But yeah, that's exactly what I was gonna say. Is that this is not the approach that we followed, which is that we designed it 52 times, and the 52nd seems to be okay. We're not verified quite yet, but we hope to be soon. So
So I'd like to take both perspectives and actually ask you, what are some of the main lessons that you have learned during this entire journey of the REXUS BEXUS program? If you could each give us an answer on that.
I think one of the biggest lessons learned is that time is a big thing. So at the beginning we had 18 months. Now we have like 12 months more, but time is always a problem, and many things which we have to rely on in some cases have turned out to be quite complicated. For example, the manufacturing of our PCB. So our PCB is kind of complex. So we have very small structures in the reason of some ICs on the PCB. And so the manufacturing process was difficult. So we were not able to use a normal Chinese PCB manufacturer. So yeah, and then we found a manufacturer which also is a sponsor of our team, but we had to wait for I think half a year after it was manufactured, and in that time we were not able to go further on with the electronics. So yeah, time was a big problem, and also the planning. So if you were able to know that you have to wait half a year, you could plan something, but it's always like, yeah, next month it will be there, or next month it will be there, and then there are 6 next, half a year is gone.
Did you say that was about the PCB that you contacted
Yeah.
a Chinese manufacturer and you had to wait 6 months to get it?
Yeah.
No,
Oh,
you
no.
contacted.
Yeah.
We are actually
No,
communicating. Yeah, I'm sorry. Please.
we had a German manufacturer from our town where we are placed, and it's a sponsor, so we not like a normal customer. Maybe when we have been not a customer, it would be easier. But yeah, we had to wait for a very long time. But I think also COVID was a problem. So and
Oh.
these ship and the what was the
It
name?
was too complex for a Chinese manufacturer. That's
So sorry, that was the
yeah.
question.
That's yeah.
Okay, well, we have neither of these problems, neither COVID currently nor too much of a complex PCB. Because the reason I repeated the question is because, well, we just sent a request to a Chinese manufacturer to receive a PCB, and we expect to receive it within the next month. So we got kind of worried.
You got us stressed.
Yeah, but it's a simple piece.
Yeah.
So please go on with your answers about the lessons.
Yes.
Yeah, for me, I think for me it was the point we just discussed before that it was good that we do a lot of hands-on stuff because I think you can relate. You only can conduct a viable analysis or simulation if you have at least some feeling or know a little bit about your data, about your stuff. So it was good to do a lot of hands-on work, but I think a little bit more of research, planning, calculating in the beginning, and discussing the design more thoroughly would have been good.
Mm-hmm.
And also system engineering is a big fault in our team. At the beginning, the mechanics and the electronic team did like their own project, and then we often met and are like, "What are you doing? We not talked about."
Okay. I guess I have to put a new sound effect on the interview.
Yeah, that's gonna be the first bleep.
Yeah.
You get the honors of having the first bleep on the,
Oh.
interview.
PG rated.
Yeah.
It's okay.
Yeah.
It's the live interview.
The YouTube, when you try to upload on YouTube, it asks you whether it's for children or if it's 18 plus. So we're gonna
Okay,
have to
guys.
keep it for children.
No, when we
Okay.
after the interview, we're just gonna say a lot of words. That's word.
So,
No.
Timon, about your answer, please.
Yes. So the good thing about having a former experiment at so we had two former REXUS experiments on our university. Or one was
Three.
BEXUS? 3? Okay, sorry. We had very similar experiments to like understand how the whole REXUS circle goes, but for my part, it was really nice to have like a foundation to work with, but from a management perspective, we relied a lot too much on the stuff we had from game. And then the further we went on, the more we realized each experiment is unique and has its own problems. And because our experiment expanded on some of the stuff, we had like very, very different approaches than they had. But because it was like the first time of from each of us doing something, like we should have learned it by doing it, but we started a lot with the stuff we had from game, and in the end, I think it would have been better to just go our own way from the beginning. But yeah, we still went our way, so that's okay.
I see. Well, you did learn a lot of things, but that's exactly what the REXUS BEXUS platform is about. I mean, the main product is not just the knowledge that comes out after the experiments, but also the scientists and engineers that come out of this platform with experience and ready to take on a larger and significant projects. So, as is customary, I would like to end the interview with one of our favorite questions.
You're stealing my last question.
Yeah, I am. It's the first time I'm asking it instead of Costandina. So, could you please tell us what will be your experiment's contribution?
May I ask first, is that the part where boomerangs got spicy, or was it earlier?
No, it was the question about their experience on the program that got spicy.
Okay.
I don't
Because
know what this alleged spiciness is.
Perhaps you should see the interview.
Yeah, no. I watched. Oh, never mind. Let's continue to the question.
I think our contribution first to implement more project-based and or to implement more students projects like this at our university. For example, we just started an association like you have to maybe to inspire other students to do something similar. This is one contribution we make.
Yeah, and I think the general gain of interest about such experiments. So we have a lot of people in our departments or in the whole university who doesn't know that such options to contribute and such programs exist, and with us they are able to know. I think that's also a thing, and I think as we told you about, we're also planning to give the atmospheric research a contribution with our platform. Maybe it will not work, but we hope it will do, and then this will also be a small or big contributions.
Maybe to add on that, we went through a lot of hurdles to gain interest or sponsors for our experiments from the side of our university. Like we have very good support from our professors, but from university side, it could look better, to be honest. And we actually want to flatten the hills for our future teams. And for this, we, like Felix said, we founded a student association which deals exactly with this. And in Germany, there's like very complicated process to gain something for student associations, and we implemented that and hope this to be like the foundation for the future work.
Great. Thank you for your answers, and thank you for participating in Discussions in Orbit, Team GAMEon. It was a very fun interview, and we wish you all the best on your experiment. And in order for me to steal your line now, see you on the rocket.
Thanks for having us.
Thank you.
Thank you. Bye.
Bye.
Goodbye.